In this video, I'm gonna go step by step through the process of simplifying this expression using multiplication, division, and factorization into this smaller expression on the right. So this is the expression that I start with. What is the first step that I'm going to take? Well, it might seem like a little trivial step here, but I am going to take this 9 and I'm going to rewrite it as 3 squared. Remember, 3 squared is 3 times 3, which is 9, so these two expressions are equivalent, but this will help me later on in the exercise. Now, as a second step, please take a look at this exponent 2. This exponent 2 gets multiplied by each one of the exponents inside of the parentheses. Remember about the properties of exponents. If you have two numbers being multiplied, in this case a and b, and they are in a parenthesis with a square, an exponent 2 in this case on the outside of the parenthesis, that is just the same as having a squared times b squared. But if the number inside of the parenthesis has an exponent different than 1, then you have to multiply those exponents. For example, x to the power of a, and all of that in parentheses with another exponent b that just equals ax with an exponent that is a times b. So if I have a squared multiplied by b squared, and all of that is in parentheses with another square on the outside, that just equals a, and the new exponent is going to be the exponent that I had, 2, multiplied by the exponent outside of the parentheses, which is another 2, and 2 times 2, 4. So that's what I have. That's why I have a with exponent 4 multiplied by b with the exponent also 4. So back to the simplification here. That's exactly what I'm doing. What happened? Here we go. That exponent 2 is going to get multiplied by the exponent of each one of the numbers and the variables inside of the parentheses. So here we go. 3 squared becomes 3 with the new exponent 2 times 2 becomes 3 to the 4th power. X with an exponent of negative 2 multiplied by 2 becomes x with an exponent of negative 4, and y already had an exponent of negative 4, and I multiply that by 2, so y now gets an exponent of negative 8. So that's where I am up to now. Next thing I'm gonna do is start working on this parenthesis right here. As I did before with the number 9, I wrote it as 3 squared. I'm gonna write the number 32 as 2 to the 5th power, 2 with an exponent 5. Remember, 2 with an exponent 5 is just 2 multiplied by itself 5 times. If you do that, you're gonna get 2, 4, 8, 16, 32. 2 multiplied by itself 5 times equals 32. So I just put here 2 to the power of 5 instead of the 32. These two expressions are equivalent. And that's where I am up to now. I eliminated the exponent from this parenthesis, and I just change the 9 and the 32. So what I'm doing here is just rearranging the terms. I'm putting all the numbers together, I'm putting all of the x's together, and I'm putting all of the y's together. Now I just have multiplication. I can do that because I don't have addition and because I don't have exponents outside of each one of the parentheses. Why didn't I do it before? Well, for example here, all of these numbers are being multiplied and then multiply by each other. I don't need those parentheses because all I have here is multiplication. And what I did was that I rearranged them into the even numbers first and the odd numbers later. If you do this in your calculator or by hand, you're gonna get the same result in this way, and changing the order, you're also gonna get the same result in this way. In multiplication, changing the order of the numbers does not change the final result. Before, I just could not do that because I had to take care of the exponent first. So I cannot go and just change the order of these numbers and completely forget about this exponent. These two are not equal. If I have the exponent there are many things that I can do. One could be take these numbers 2 times 3 times 4 and write them twice, multiply them by itself. 2 times 3 times 4 squared is nothing more than 2 times 3 times 4 multiplied again by 2 times 3 times 4. However, that was not what I did. What I did was that I applied the exponent to each one of the numbers inside of the parentheses. This is what I did in the previous step with the variables x, y, and the numbers. So once I have it like this, there are no exponents outside of the parentheses, so I can just get rid of the parentheses, and since I have no addition, no subtraction, only multiplication, then I can rearrange them as the even numbers here and as the odd numbers here. But now look at the influence of the squared. 2 and 4 are squared because they were squared in the previous step, because also there was a square outside of the parentheses. And here in the odd numbers, the 3 is squared because of the same reason. If you remember this property again of multiplication, doesn't matter what's the order, as long as they are all being multiplied, I can rearrange them any way I please, as long as it helps me with the simplification and solving the exercise faster. So that's what I have. I have the numbers first, the variables x in the center, and at the end the variables y. So what I'm going to do now is I'm going to multiply x to the power of -4 times x to the power of 5. And what is the result of that? But remember the property of exponents. If you have two similar bases with different exponents, that results in the same base and the addition of the exponents. So here I have x with the new exponent being -4 from one x plus 5 from the other, and -4 plus 5 is just 1. So x to the power of 1 is just x. I don't have to write the 1, I just say x. So what I do is, where I have the two x's before, I just have an x now. I multiply together these two x's, the result was just simply x, and I put x in there instead of the other two x's that I had before. So here's where we are up to now. Let's start working on the y's. Same process here. Y to the power of -x multiplied by y to the power of 9. I add the exponents, becomes y, and the new exponent is -8 plus 9. -8 plus 9 is just 1. I forget about writing the 1 and just end up with y. And where I have the two y's before, now I have a single y with an exponent 1 that I don't have to write, so I just have x and y as a result. This is where we are up to now. Another step that I'm going to take, because I'm going to start working on the denominator now, is that I'm going to write 54 as 2 times 27. 2 times 27 is 54, so these two expressions are equivalent. But if you look here, 2 times 27, the 27, I can write it as 3 cubed. 3 times 3 times 3 is 3, 9, 27. So those are equivalent. And I think you can see where I'm going with this. And if you don't, you're going to see very soon. Now, as it happened before, I have an exponent 2 outside of the parentheses that applies to each one of the numbers and variables inside of the parentheses. So each term I have to apply the exponent 2 to each one of the terms. What do I get? Well, 2 had an exponent 1, which is not there, but you know, anything that does not have an exponent actually has an exponent 1. So 2 becomes 2 with a new exponent, which is 2 times 1, which is simply 2. 2 becomes 2 squared. 3 becomes 3 with a new exponent, which is 3 times 2. The exponent that I already had multiplied by the exponent outside of the parentheses becomes 3 to the 6th power. X becomes x with an exponent of 2 times 2, x to the 4th power, and y, it was y to the 4th power, and that 4 multiplied by 2 becomes y to the 8th power. So here we are up to now. What's next? Well, I can start by working with the y's. Now the y's, I have a y on the numerator and y on the denominator. So if you look at the properties of exponents, you have a division of numbers with exponents. It becomes y with exponent 1 divided by y with exponent 8. That equals the same base number y, and the new exponent is going to be the exponent of the numerator minus the exponent of the denominator. So in this case, it's going to be y to the power of 1 minus 8, and 1 minus 8 is y with an exponent negative 7. If you remember, any number variable with a negative exponent equals 1 divided by the same variable, the same exponent, but in this case, instead of negative, positive. So y divided by y to the 8th power is simply 1 divided by y to the 7th power. But if you want, the way I do it, instead of having to do this subtraction, I have a little faster method that I do. I think about these two as going into a battle to the death. The two of them are going in, only one will survive. Which one will survive, the numerator or the denominator? Well, knowing which one is going to survive is the easy part, because the one that will survive is the one with larger exponent. And here we see the numerator has an exponent of 1 and the denominator has an exponent of 8. So the one on the top is the loser. It has less exponents, so it goes away. That's why I only have a y in the denominator now. But during the process of that battle, the winner takes some losses too. The winner will end up with less exponent that he had when he entered the battle. How many less exponents? Well, in the process of losing, in the process of eliminating the one on the top, the one on the bottom lost the same amount of exponents that the one on the top had. So he entered the battle with 8 exponents, with an exponent equal to 8. His enemy had 1, that's the value of his exponent. He won, but now he has 7 exponents. The 8 that he had before minus the 1 that the loser took away with him. So the new value is y to the 8 minus 1 from the loser, y to the 7th power, and it is in the denominator. It is in the part on the bottom part, because in the bottom part is where we had the larger exponent. So the one on the bottom is the one that survives. That way I can memorize it faster, and I know that at the end of the day I'm going to have our variable in the denominator and just a 1 in the numerator. If I do it this way, and I do it quickly, and for some reason I forget to put the negative here, I get confused and I say 1 minus 8 equals positive 7, when then I can possibly leave the 7 on the numerator and get a wrong result. Or maybe you put here 1 minus 8, you forget, and you just write 1 plus 8 in your head. Say that this is y to the 9th power, and end up with y to the 9th power and nothing in the denominator. This way I know quickly that the variable is going to stay in the denominator, and I know also what's the value of the exponent is going to be. It's the value of this exponent minus whatever the one that got eliminated had before. So y divided by y to the 8th power becomes just this 1 divided by y to the 7th power. I don't have to write the 1 because the 1 is going to get multiplied by all of this, and all of this times 1 just equals all of this, so I don't have to write it. I just put the y to the 7th power in the denominator. Now I do the same with the x's. These two go into battle. Which one will survive? The one with the larger exponent, the denominator. So this is the one that survives. The other x disappears, just becomes a 1. But he loses exponents in the battle. How many exponents does he lose? Whatever the one on the top had. The one that lost had 1 exponent. He had 4. He won, but he ended up with 4 minus the one that this one had. So he ends up with 4 minus 1, exponent 3 in the denominator. So I do the same thing. I don't have to write the 1. Again, the 1 gets multiplied here. This times 1 equals this. Forget about writing the 1 and just put x to the 3rd power, or x cubed, in the denominator. We had x and x to the 4th power before. Now we just have x cubed in the denominator. And this is where we are up to now, looking more simpler than it did before. So what else do I do? Remember, I did nothing here but change the order. The 2 to the 5th power, I put it in the front, and the 3 to the 4th power, I put it in the 2nd place. This times this is the same thing as this times this. Changing the order does not change anything. These two expressions are equivalent, so that is the same thing. Now, as you can see, it just looks nicer. So here we have the same type of battle that we had before with the x's and the y's. These two numbers 3 go into battle. The 3 on the numerator and the 3 on the denominator. Which 3 will survive? The one with the largest exponent. This is the larger exponent, so I'm gonna end up with a 3 on the denominator and no 3's on the numerator. This one, in the process of the battle, is gonna lose a few exponents. How many? It's gonna lose 4. The 4 that belong to the one that lost the battle. So if it had 6, lost 4, 6 minus 4 equals 2. So I have a 3 with an exponent 2 in the denominator, or 3 squared. I started with 3 to the 4th power divided by 3 to the 6th power. I end up with just 3 squared in the denominator. So I guess you know what the next step is going to be, right? What do we do with these numbers 2? Again, we go into battle. The number 2's go into battle. Which one will survive? The numerator of the denominator. The numerator has the larger exponent, so I'm gonna end up with a number 2 on the numerator and no number 2's on the denominator. How many exponents does the winner get to keep? Well, 5 that he had before minus 2 that the loser took away. 5 minus 2 equals 3. So I have 2 cubed, 2 to the power of 3. Now I just rearrange it so that it looks a little nicer. And what I end up with is 2 cubed on the numerator, and in the denominator 3 squared, x cubed, and y to the power of 7. I can leave it like this, or I can just perform that multiplication. 2 cubed is just 2 times 2 times 2, which equals 2, 4, 8. 2 cubed is 8. And 3 squared is 3 times 3, which is 9. So I think that it looks nicer like this. 8 divided by 9, x cubed, y to the 7th power. And that is how we get from this big expression over here all the way to this small, compact, simplified expression.